All right, guys, so today we're going to be talking about solving inequalities. And inequalities are things that you've seen before. You treat them almost exactly like equations, except you have to remember a couple rules. So we're going to treat this just like an equation, right? We are going to distribute this 2. So we get 5x plus 2x minus 2 is less than 6x plus 4. I'm going to combine my like terms. 7x minus 2 is less than 6x plus 4. I'm going to subtract 6x, so I'm going to end up just with x, and I'm going to add 2 to both sides. And you end up with something like this. X is less than 6. Well, the way that we show that answer is on a number line. We're going to have an open dot at an open dot at 6 because it's not equal to 6. It has to be less than. And where are all the numbers that are less than 6? They're this direction. They're 5, 4, etc. All right, let's try this next one. I'm going to distribute this negative, I'm going to distribute this negative 6 again. I'm going to get 4x minus 6x minus 6 is less than negative 10. I get negative 2x minus 6 is less than negative 10. Add 6. And then divide by negative 2. Now remember, if you multiply or divide by negative 2, you have to flip the sign, right? So I need to make this less than sign greater than. So I'm going to get x is greater than 2. And we go ahead and we graph that, right? It's going to be an open circle at 2 because it's not equal to 2, it's greater than. Where are numbers that are greater than 2? Right there. All done. All right, so what we're going to do next is we're going to talk about a couple notation things. So if I have a bunch of numbers, okay, let's say I have just like a whole bunch of numbers and I can list them. And what I mean by listing them is like I know exactly what the numbers are. Let me explain. List notation basically means we list all numbers in a set. So for example, I'm going to use this little curly brace. Let's say I know the numbers 1, 2, 3, 4, and 5 are in my set. Okay? We can just list them. There's 5 numbers. They're super easy to list. What about if I said, hey, all the numbers less than 12, right? Inequality notation says we're using all of the inequality symbols, right? Maybe does not equal to. These are called the inequality because it doesn't mean they're equal to. Right? This means I could say x is less than 12. So that is a different notation, right? Notation is basically how we write something. So here we have list notation where I just list the number. Here I have inequality notation where I kind of write my inequality, right? And then what about a graph or number line? This is going to be a visual representation, right? So that could be, if I said, hey, I want to find all the numbers between 3 and 4 that are greater than or equal to 3 and then less than 4. So we can see there's a visual representation in using a graph, which is really nice because it's, for those of us who are visual learners, you just look at the graph and it tells you. We also have this thing called set builder notation. So this is, we use this less, but let me explain what this means. I'm going to go ahead and write this. This says variable, then we have a straight line, and we have a rule. Okay, the variable basically means, or sorry, not the variable. I pointed at the wrong thing. This symbol right here, that little curly thing, means the set of. And that also means the same thing here. But then we talk about this guy, this symbol right there, means such that. Okay? So you would say, I'm going to give you an example and it's going to make a little bit more sense. The set of x's such that x is less than 5. That would be set builder notation. We're saying the set of all numbers x where x is less than 5. Now, you could easily write this in inequality notation, right? All you would have to write is this, which makes a lot more sense, but this is just called set builder. A really difficult example would be something like this. The set of all x's such that x belongs to, this means belongs to, the integers. This is when you get really fancy, and we won't use this as much, but just so you guys see, this means integer, this means belong to. So that's called set builder notation. And essentially it is like, here's our variable and here's our rule, essentially. So now there's this other one, and this is the one I want you to pay really close attention to. This is called interval notation. So kind of pay close attention to this guy. Interval notation, if I were you, I would write a little note to yourself. It's basically like left and right endpoints, right? So here's what and then you can either have parentheses or you can have brackets on the outside. So parentheses indicates you don't include the endpoints. You don't include endpoints, right? That basically means we have open circles or greater than or less than, right? Or less than and greater than, right? Brackets indicate you include the endpoints. And I know that it doesn't make a lot of sense yet, but it will just here in a second. So for example, if I said the numbers between 3 and 8, this is inequality notation. If you want to do interval notation, well, what's the leftmost number? 3. What's the rightmost number? 8. Easy, right? And because we're not including the endpoints because they're not equal to, we'll use parentheses. What about this next one? What's the left point? -4. What's the right point? 0. And because this doesn't have an equals, we'll use a parentheses. And because this one does, we will use a bracket. I'm gonna make this thinner. There we go. X is greater than 5. Well, let me draw that on a number line, right? It's all the numbers greater than 5. So what's the left endpoint? Well, that's 5. What's the right endpoint? Oh, that's infinity. It goes forever to the right. Okay, since this is an open circle, we'll use a parentheses. And we actually always use parentheses with infinities. Okay, so no matter what, we'll put in a parentheses there. X is less than -2. Well, let's draw a picture of that. This is -2. It's less than or equal to its closed dot, and it goes to the left. So what's the leftmost point? Oh, it's -infinity. What's the rightmost point? -2. Always use a parentheses on infinity, and because it's a closed dot here, we'll use a bracket on the 2. So interval notation as a whole is just left and right endpoints. So we can kind of go between all of the different notations pretty easily. So for example, we have the inequality x is greater than 3. So what's the graph? Well, we have a 3, we have an open circle, and it goes to the right. Set builder would just be the set of all x's such that x is greater than 3. Whoops, that's a little curly guy. So this one, set builder again, is it's almost just like a harder version of the inequality. Interval notation, let's see, the left point is 3. It goes to infinity to the right. Open, open. Let's try another example. This is saying the set of all x's such that x is between -2 and 7, right? This is pretty easy because the inequality is just this part, right? And the graph is also pretty easy because it's between -2 and 7. We'll have a closed circle here and an open circle here. What's the interval? Oh, it's just -2 to 7. We'll use a closed bracket here and a parentheses there because you just match what the graph would look like. All right, let's see our final example. This says -infinity to 4. So I'm going to graph this first. On a graph, it's going to be -infinity. Oh, and it stops at 4 with an open circle. Well, isn't that just going to be x is less than 4? Isn't that set builder going to be x such that x is less than 4? And that's it. So you can see you kind of move between all of the different notations pretty easily. And they all kind of mean the same thing, that they're just sometimes that it's easier than other things. So what happens if there is a gap, right? What happens if there's something in the middle? So there's a big symbol that we will use, and it's called the union symbol, which is just this big U. So let me show you the graph. If I have the graph that says x is less than -4, I'm just going to draw one big graph. X is less than -4, but it's greater than or equal to 3. We do it on the same graph, and here's how we do it in interval notation. We just do two different interval notations. So let's look at this first one, right? This one. This goes from -infinity to -4. Oops, that's really hard to read. -infinity to -4. So we always use parentheses with infinity, and it's a parentheses because it's an open circle there. What about this next one? Well, it goes from 3 to infinity on the right side. We're going to use a bracket here and a parentheses there, and then you just stick a union in the middle. It just means you put those two together. That's it. All right, let's try another example. All right, I'm going to do this one first. X is greater than 12. I'm going to have an open circle, it's greater than 12. Or it's between -3 and 5. We're going to have an open circle here and a closed circle here. Right? And it doesn't really matter that your scale is perfect down there. That's fine. So here's what I'm going to do. Interval notation. Start with the left. -3 to 5. Let's see, open, closed. Let's see, 12 to all the way to infinity. Open, open, because infinities are always open. And just stick that in the middle. So you can see that this is a very simple representation of the graph. And it's basically saying left and right endpoints. That's it. So that's all we have for inequalities. Make